Okay, picking up where we left off on page 20, we're talking about prototyping. And one of the interesting things that you'll discover when you become a systems analyst, providing, of course, you do become a systems analyst, is that an awful lot of times the customer has no clue whatsoever on how to talk to you about their requirements. They cannot do it. They cannot articulate their needs. You can go sit down and interview them and say, okay, now what is it this new system is supposed to do? And they'll mumble a few words and you'll walk away thinking you've got it all. And you won't discover later that that's not at all what they had in mind. Well, one way to kind of help with that is with this prototyping. You show up and say, now this is what I heard you say and here's what it's going to do. And they'll look at it and go, well, why on earth did you do that? And of course you'd think to yourself, because you told me to. But we don't say that out loud. And you go, well, what did you really need there? Oh, well, I want to do this, this, and this. So that iterative process of early prototyping really helps with the communication between the developer and the actual user of the product. So it's very, very helpful in solving problems early on. And trust me, you don't want to wait until the end of the project to show off the new toy and then have them look at it and go, what on earth is that? And you go, well, you told me you wanted a such and such feature. And they go, no, we didn't. You go, well, I got the notes. Yeah, you did. Because they really can't articulate their needs. So it does speed up the development process because you get early feedback. And it's useful in this fact-finding and modeling techniques, and because it really gets you really, really close to the user and say, here's what I heard you say. On page 20, they talk about some fancy tools, the CASE tools, computer-aided system engineering tools. If you had that goofy little card that went with the book, you could log on to their system and play with some of their CASE tools. We're not going to do that this particular semester, but there's some pretty cool tools that kind of help you with this kind of modeling techniques. So some of them are quite good. Most of them are quite expensive. There are some CASE tools that are just modeling tools. Like for example, Microsoft Visio, a very cool way of doing modeling. And you could say that Visio was a CASE tool. You could. I mean, a very crude one, but nevertheless, it does provide a really cool and interesting way of doing modeling. Okay, most CASE tools go beyond modeling, and they actually help the developer actually write some of the code. Okay. On 21, they talked about the techniques. There are three major techniques that the book talks about. The first one is the so-called structured version, the traditional structured, going over the 5 steps we talked about at the very beginning of the thing. This is the traditional system development life cycle, the so-called waterfall model. And the book is kind of organized along that. Now we branch off and talk about these other techniques, but the book is organized as if the entire thing was done with the SDLC approach. Object-oriented approach. In the traditional approach basically talks about, here are the functions, and here's the data that needs to be done, and here's all the things. Object-oriented approach makes a very, very, very tight tie between the data and the functions that operate on the data. It marries them together. So for example, in an object-oriented world, when you're trying to solve a problem, you look at a customer. A customer has data, and a customer has all these other things that a customer can do. The customer can call in to place an order, or on the web get an order. They can return an order. They can dispute a credit card claim. All the actions that this actor can do for the system. And it actually helps, believe it or not, in the development part. If you're a systems developer for a living, you actually kind of prefer using the object-oriented approach because it more accurately describes how you're going to define the database and how you're going to write the code. And the last one is called Agile. And Agile is a relatively new approach. And Agile kind of goes like this. We're going to jump in. We're going to involve the customer at every step. We're going to set up weekly meetings with the customer. We're going to show off prototypes. We're going to get their feedback, and we're going to kind of stay loose on our scope, and we're going to allow them to change their mind and change direction and change technologies. And this works really, really well if you have an in-house team that you're working with, and you want the latest and greatest technologies, and you have a very technically competent user base that you're going to interview. Now, this doesn't work well if you're working in an insurance company and you have a bunch of insurance adjusters, and they don't care anything about automation. That's not their passion. That's not what they do. And then Agile team comes in and says, "I'd like to set up a meeting, 1 hour meeting once a week to discuss this new prototyping of this new system." And they're going to go, "I ain't got time for that. Go away," because they don't have an interest in it. It's not exciting to them. They don't really care, and it's more of an intrusion. And even if you did get them to agree to go to the meeting, they probably sit there and go, "Yeah, okay, that's fine. Whatever you guys think is fine." They're not really interested. So if you have I'll dare say a young, interested, energetic organization, Agile works fantastic. It actually produces the best results. However, it's not suitable everywhere, and you could have a problem with meeting deadlines, because with the traditional life cycle, I can kind of sort of know how long the project's going to last, how much it's going to cost. With Agile, not quite so much. You could get halfway through a project and then it spins off in some other direction. The customer is usually very, very happy, but how long does it take to do one of those things? How much is it going to cost? Don't know. Okay. So on page 22, they go a little bit more detail. The structured analysis, the one we've been talking about, the time-tested and easy to understand, SDLC. It's been around for a long time, and a lot of people are still using it. And it is a predictive approach. It can kind of sort of tell you how long it's going to take. And it uses process models to describe the system. All right, I'll go along with that. And it also uses this so-called waterfall. These are the steps you go through. So, planning. And by the way, I don't know why they didn't use the same colors here as they did in the book. Wouldn't that have been kind of cool that we're in the planning stage? And shouldn't that have been green to match the color coding in the book? Perhaps that's in the note to the author. Okay. Planning, followed by system analysis, followed by system design, followed by implementation, and then you end up with maintenance and upgrades and security and those kind of support kind of scenarios. So it actually starts, one step follows the next, follows the next, follows the next, follows the next. And that works fairly well. So following along that, page 23, talk about system planning. It's the system request. Begins with the process. It describes the problems and the desired results. What is it you're trying to solve, and what is it you want this thing to do? And the purpose of this phase is to perform that preliminary investigation. Very critical. I know systems that have started, and you get halfway through them, and then you finally figure out that that's not at all what the heck they had in mind. And it's frustrating as hell, because normally you just stop the project and say, well, okay, I guess we won't do this one. Okay. And yes, it's a key part in that preliminary investigation is a feasibility study. And feasibility could mean time. Do I have enough time to do this? Do I have enough money to do this? Is it technically feasible? And we're going to go through this in a lot more detail in the next chapter. But there's a whole series of feasibilities, not just one, that say, yep. So you're going to use that first part to decide if you're even going to do this project at all. Okay. Okay. So next on page 23 to 24, they talk about the systems analyst phase. It builds a logical model of this new system, kind of a fact-finding kind of a scenario. It builds the business model and the data and process models and the object models. And when you're done, this kind of becomes the requirements document. And in a traditional system, this is where you get the people to sign off and say, here's what the requirements are. Sign your name here, because if you change the requirement, it's going to cost you money. Because the worst thing that can happen in a project is they come in and they say, here are the 5 things I want this thing to do. Boom, 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 boom. You go, great, I'm going to go out and hire me 10 developers, and we'll have this thing done in 6 months. And then on the third month, they say, well, we also want to do this. And you go, I don't have enough people. I don't have enough time. It's going to cost you more money. So getting that requirements agreed upon, everyone agrees to it, everyone signs off on it, signs their name that says, yes, this is what I'm asking you to do. Because let me tell you, the number one problem you're going to have as a systems analyst is requirements. And people are going to be wanting to change requirements. Gee, does that sound like a test question? Okay, continuing on page 24 about the actual system design. This is when you actually create the physical model, design the user interface, identify all the inputs and outputs and reports and those kind of things. And you end up with a design specification. This is what you use to go out and hire people or buy stuff. So the system analyst says, yes, this can be done, it's feasible, and here's how long it's going to take. After you're done with the system design, you go, okay, I'm going to have to hire these people and buy this software and buy this hardware, those kind of things. The next step is, of course, the system implementation. You get all the people in, get all the hardware and software in, and you actually put it together. The new system is constructed. The programs are written and tested. The system is installed. And then when you're done, the deliverable for this step is a fully functional system. Now, you're not done, not by the slightest imagination, because handing them over, okay, here's your new system, is going to be disastrous. You're going to spend an awful lot of time doing training. So one of the things you're going to do is put in your plan, here's how I'm going to train the new employees, here's how I'm going to leave training instruction behind so that after I'm gone and they hire new people, I don't have to come back to train the new hires, those kinds of things. And then last, we're talking about the system security, support, and maintenance. No system is always perfect, and you're going to have to go back. You're going to have to do patches. You're going to have to do changes. You're going to have to do security kind of things. I mean, it's just inevitable. And so you need to have a system in place. And if you're a third-party company, a lot of people make a lot of money in this last section because they'll lowball the design and the implementation part, and then knowing full well that you're going to sign up for a 1-year contract for doing maintenance. That's how companies like Oracle make a lot of money. Okay, so it's got to be secure, it's got to be reliable, and then of course you have to update things from time to time. It just happens. Okay, continuing on page 24, they talk about the object-oriented analysis approach, and we're going to get into this in a lot more detail, so we can kind of skip through this. But the whole point is it does combine the data and the processes together. And these things have names. Whenever you have like a customer has methods. And methods are just the things that a customer is allowed to do. A customer can order something. It can, do this. They can pay their bills. They can do. All the things that a customer can do are considered methods. It doesn't actually matter what you call them. However, you kind of sort of need to know those terms, because when you're talking to the developers that you hire, that's the terms they're going to use. They're going to say, well, let's talk about this order method. And you're going to say, method? What the heck are you talking about? So that's just the language that the object-oriented programmers use. Okay, and on page 25, they talk about Agile. Agile is cool, no doubt about it. Rapid prototyping, getting the users involved early, lots and lots of changes are allowed. Very cool system, and it's really great. There is a group in Austin called the Austin Agile Users Group, something like that. And these guys are fanatical. I mean, if you go to one of their meetings, you think you're in some sort of a church. I mean, they're up there at the pulpit, preaching the gospel of Agile programming. It's really spooky. These guys are really energized on using Agile. Unfortunately, my personal opinion is Agile is fantastic and can be used about half of the scenarios that I'm familiar with. Okay, once again, we're at the 15-minute mark, so we're just going to stop, and I'll pick this up again in a few seconds.